All right, so remember, well, let me read this and then we'll go from there. So it says, what is the force on a charge located at x equals 8 centimeters, given that Q represents 1 microcoulomb, right? So this is 5, 6, 7, 8. So there's a charge here, right? And then they give us two scenarios. So this is 8. Well, keep in mind that there's a force, because this is positive and because this is negative, there's an attractive force. So this will want to go, let me undo that. We'll make it a little smaller. Let's just do this. This will want to go in this direction, and then this will want to go in this direction. So remember, force is a vector, so you're going to have a positive and a negative, right? So we could call this force, and I'm going to label this is 3, and then remember this is 8, and then this is 11, right? Because that's their position. Well, there's an attractive force. There's two forces pulling on it, right? And because this is, well, let's just do the math. So this would be the force between 3 and 8. That's a 3. And then this would be the force between 8 and 11. Okay, so then to find the overall force, remember that the force, the way that we find the capital K, Q times the second Q divided by the distance between them squared. So if I apply that here, I'm going to say that my overall force is equal to capital K Q3, right? Q8, and we'll plug those numbers in a second. And then the distance between 3 and 8. So I'll say 3 to 8. And I forgot to put a comma up here, so you put the commas here. And then minus, right, because the force, there's an attractive force. Would be minus K, Q8, Q11. All over the radius squared. I forgot to square this. Between 8 and 11. Okay? You guys with me so far on that? Okay. So then we just plug in the numbers, right? So on the next line, and you can factor out the K, right? So if I factor out the K, in other words, I'm multiplying both terms by K. Remember that K is 8.99. That's a constant. Times 10 to the 9. Yes.
In the book,
They just use 9.
Yeah.
This is what they have in the solution manual. I'm not worried about it.
A lot.
Yeah. It depends on your significant figures, I think. So I'm just happy if you guys like get the plug in the numbers right. So now charge charge 8 is -2, right? And then charge 3 is 1. Let me think for a second here. Oh, actually, Okay. So this is an interesting one. Mathematically, so I'm just going to do it, and it'll be an interesting one. So what is the charge for Q? 1 microcoulomb. So we're just going to say 1 times 10 to the negative 6. And then we have also, we're going to multiply that by negative 2, also multiplied by another Q, which is 1 microcoulomb, or 10 to the negative 6. All over the distance between them. Now the distance between them is 5 centimeters, right? But we have to convert that to meters. So that ends up becoming 0.05 meters squared. Now that is just the first charge. I'm going to have to move this over. Now you could shorten this a little bit. I'm going to say minus, same thing, I'm going to have negative 2. It's the same exact charge, right? But I'm going to rewrite it like this because it's a little easier. I'm just going to say this times 1 times 10 to the negative 6 squared. Right? So if you go back up and you look at that, this is Q1, this is negative 2. So you have Q times Q, which is Q squared, times negative 2. This is a shorter way to do it. And then the distance between those is going to be 0.03. So 0.03 meters cubed, or squared, I'm sorry. And that's my parentheses on that. So now if you plug this into a calculator, you get a positive 12.8 newtons. Now because it's positive, what does that tell you? Huh? To the right. Right. So this is going to the right. And so let me explain why that is. These are equal charges, but because this one is further away, it has less of an impact on it. So when you're basically whatever this charge is, the overall net force is going to be a positive 12.4 in the positive direction, which would be to the right. How do you guys feel about that one? A lot easier? Okay. All right, let's do part B. Well, I gotta leave something for you guys to do, so I'll just leave you guys to do part B if you need to.
There's no part B. Yeah, this is the second line. This is line A. This is line A.
It says for that one only do figure A.